Hello. Hi guys, good morning. Can you hear me? Hello.
You can hear.
Yeah, bro.
Okay. Okay, let me start the class.
Okay.
Okay. So we came to end of our DevOps training. So as we committed, so we have completed all the tools related to the DevOps. So we are the final stage of the DevOps. So we have left with one more topic in the DevOps, that is Kubernetes. Okay. So Kubernetes is very important, guys. So if your resume is having the Docker and Kubernetes, so you will get the high resumes like if you have good knowledge in the Kubernetes. So 90% of the companies are looking for the Kubernetes with Terraform. Okay, Kubernetes with cloud, any platform is fine. So if you want to know the Kubernetes, first of all, we need to know the Docker basics. So if you don't know the Docker, we will not understand the Kubernetes. Okay, so we should know the Docker terminology, then only we can perform the Kubernetes set. So advanced version of Docker, we can call it as a Kubernetes. Okay, so Kubernetes completely deals with the cluster management. So what is meant by cluster? It's a group of servers. Okay, group of servers. So everywhere, if it is considered as a group of servers means, so there will be a controlled server will be there. Controlled server, master server. Okay, so the server where we are going to take the controlling part. So that server we are going to call it as a controlled server. So which servers, remaining all the servers which are present in the cluster, somebody will call the slave server, somebody will call the node servers. Okay. Okay. So this is called as a cluster management. Okay. So Kubernetes completely deals with the cluster management. Okay. So here a lot of people will use the Kubernetes activities. So one through cloud. So if you are going with the AWS, so they will ask about the ECS as a Docker, means Elastic Container Service. Okay. So in the interview perspective, they will ask it. Okay. So do you know the ECS, EKS? So ECS and EKS are completely deals with the Kubernetes, Elastic Kubernetes Service. Okay. So these are the terminology related to the AWS. So what are the activities we have performed now? Same activities also we can do in the AWS. So commands, cluster, only the setup is different in the cloud, remaining all the functionality is same. So if you want to get the list of all the images, we can go with Docker images. If you want to get the list of containers, means Docker PS. Okay. So how the commands and the functionality will be everything same, but AWS is providing their own platform to create a Docker service. So here we are using the Docker registry and AWS is providing their own registry. So to upload your image. Okay. So commands and everything, volumes, spam, service, everything will be same only. But as per the AWS language, AWS terminology, we need to use to set up the ECS. Same thing if you are learning the Kubernetes. So they will ask about the, did you know work on the EKS setup in the AWS? Okay, setup is different in different cloud platforms, and remaining and the work and the terminology will be same in anywhere. So if you go for the GCP, okay, GKS. Okay, so if you go for Azure, AKS. Okay, so each cloud platform, they are providing their own services to set up their own cluster. Any cloud you take it, the setup will be different, but remaining all the process, creating and deployment, everything will be same in the all the things. Okay, so this, if you somebody ask about the EKS, you can clearly tell that I have worked on the Kubernetes, but not onto the EKS. So if you get a time or anything, how to set up the EKS also, you can get it from the online, like Google. If you do it, you can get it. Okay. So, but in the real time scenario, what are the work they will give it? So as a DevOps engineer, we should not tell no. At least we will tell that we will learn and implement it, but we should not tell that I don't do it. Okay. As a DevOps engineer, we need to perform all kind of activities related to our work, like a cloud related works, and DevOps related works. So Kubernetes is as a DevOps engineer, we need to implement everything. So it may be a cloud or it may be on premises, anything you take it. So as a DevOps engineer, we need to do it. So if you don't know the things, you can tell that please give us such time, some time, so that I can learn and implement it. Okay. So already I know the Kubernetes, but in the AWS or Azure or GCP, I don't know. So I will know how to create the cluster and I will implement the same. Okay. So these are the things they will ask in the interview perspective. So if you don't know also, no problem. In the interview perspective, they will ask about the Kubernetes related activities only. Okay. So here, when it comes to the Docker versus Kubernetes, okay. So in the Docker, we are going to build image. Okay. So if you take about the Docker thing, so here we are creating the custom image. Suppose application related things image, if you want to create it, what we will do. So first of all, I will take the base image. From the base image, I will log into the container. From the image, I will create the container. From the container, I will log into the container. So what are the changes required inside my container, like software installations, updates, packages, dependencies, everything I will keep in the container. From this container, I will create a custom image from it. Okay, so Docker will help us to create a doc with the help of Docker file. So we can create a custom image. With the Docker Compose, we can create a customized image. So same thing. So if you want to create a custom image, manually also we can create a custom image in the Docker. But in the Kubernetes, we are not focused on the building a Docker image. Okay, so if you want to work with images, we are only work on the Docker side only. So if you want to work with a custom image, already the finalized image which we are having it. So that finalized image we are going to take in the Kubernetes for deployment purpose. Okay, so if you are going to the upgradation of the image or upgradation of any images, so if you're taking about, so you need to work on the Docker side only. So image creations, always we need to work on the image. Already the image is finalized. That image, if you tell it, then in Kubernetes, we are mainly focusing on the deployment, not on the custom image creations. Okay.
Last time we have deployed also in the Docker only, sir.
Yeah, Docker we can create it. That is the difference I will tell you. Okay. So why we are not choosing Docker, why we are going with the Kubernetes, we will see one by example. Okay. So here Docker, we are focusing on the custom images. So already the image is there. If you don't want to do the upgradation version, for example, we have hospital management, we have a hospital model is there. We are adding the nurse model, like new version is coming into the picture. Like that, if you want to do the application changes, we keep on changing the versions, we keep on changing the image things. But in the Kubernetes side, so we are not focused on the images side. So developing of the image, we are not taking care of it. Already the image is finalized. This is the application image, we need to use it. Only for the deployment purpose, we are going to use with the Kubernetes. Okay, so why we are not using Docker Swarm versus Kubernetes. Okay, so Kubernetes Docker Swarm is nothing but, so as the nodes are increasing. Okay, so Docker Swarm is nothing but it's a cluster. Cluster is nothing but master and node machines are available. So as the node machines are increasing inside the cluster, so the health checks of the node machines and handling of the node machines, so little bit difficult in Docker, and it is very high in the Kubernetes. Okay, and scaling up and scaling down and handling the health checks, and Kubernetes can handle up to 5,000 nodes. Okay, so when you comes to the Docker Swarm, so as keep on, if you are having a small kind of application, so then we can go with Docker Swarm. If it is a large based application, so people not able to choose the Docker Swarm. So they are facing issues. As many the nodes are increasing in the cluster, so the health check of the node machine, the performance of the node, the performance of the application is little bit going down. So to increase the performance of application, they're keeping on increasing the scaling of the servers, like adding one more servers to the cluster. So what happens? So the performance and handling of the nodes, health checks, it is very difficulties happening in the Docker swap. So that's the reason they have found one more solutions like a Kubernetes. So it can be supported up to 5,000 nodes. You can understand 5,000 nodes means 5,000 servers we can add into the cluster. Okay, so that much capacity it is able to handle it, and it is easily scale it and easily handle the health status of each and every node. So lot of configurations, lot of options are available in the Kubernetes when it comes to the Docker. Okay, so that's the reason the people are having the lots of options are available and lots of features are there in the Kubernetes. Health checks of the nodes, health checks of the application, everything we can easily identify it. And if you are not able to hit the application, so how to track that application, everything we can handling in the Kubernetes. Okay, so Kubernetes also developed by the Google company only. So they have started for their earlier projects, like they have used it for deploying their application for the thing. So after that, they have made as an open source one. So finally, they have renamed the product to the Kubernetes. Okay, Kubernetes also developed by the Google, and it is an open source platform. Everybody can download it, everybody can install it in their local machine, and everybody can start working on it. Okay, so there are two types of things are there. So we can implement the Kubernetes in the cloud and on premises. Okay, so what is meant by somebody always speaks about on premises in the real time? Okay, so on-premises, on-premises, on-premises. This keyword is nothing but on-premises is nothing but client network. Okay, for example, we are using the client. Okay, so my client is like things like a HDFC Bank is my client. So I'm working under the client place. So their company will have their own network. Okay, so if you are deploying your application, if you are developing your application under their own network. So if you are working under the client network, and deploying and development work, everything you are doing there in their own network. So that we are going to call it as a on-premises. Okay, somebody is continuously speaking. Have you worked on the on-premises one or on demand? Okay, so on managed services. Okay, so these type of terminology they will be used in the real-time scenarios on the interview perspective also. Okay, so managed service is nothing but there is a one more concept called managed service. Okay, so what is managed is nothing but, so everything it's a platform will be provided for us. So no need to develop from the scratch. So already the platform will be provided. So if you want to create a EC2 server, what we will do? So entire platform will be provided for you. So what type of OS you wanted, what type of RAM you wanted, how much storage you required. So what are the net security groups means, what are the network rules you want to define it. So everything is provided under the EC2. Just we need to using that platform and creating the servers. Same thing in the managed service also. ECS or EKS, any service you are taking it. So the platform is provided for you. So you are provided the various options are provided for you. Just we need to choose the options from it and we can set up the clusters. So those type of things we are going to call it as a managed service. We are able to easily manage the service. So with the help of the options which are provided by the respective cloud platform. Okay. So these things we can do it, managed service. Okay. So now if you want to set up the Kubernetes, so lots of terminologies, lots of components are available in the Kubernetes. Okay. So if you are doing in the cloud, or we can also create in EC2 server. Okay. So we can set up here also or on premises. Okay. So here we can set up in anywhere. Cloud is nothing but don't care about AWS. So we have multiple clouds out there. Azure, Google Cloud. Okay. GCP, AWS, GCP, Azure. Okay. So different cloud platforms are there. So we have each platform, AWS, GCP, Azure. Okay. So here they will call it as AKS, GKS, and AKS. Okay. So these are the naming convention they will use for the Kubernetes service. So either you can set up this cloud platform, they will set up the Kubernetes in ways. Okay. So Kubernetes setup we can done in multiple ways. So if you want to set up in the single server, okay. So that is called as a single host Kubernetes setup. You can do it. So if you want to do the cluster means, so we have a master and slave servers will be there. Okay, so this single server setup, we are going to call it as a mini cube setup. And if you are going with a cluster, so they will have a COPS methods. Okay, lots of methods are available here. So either we can go with a single server setup or for cluster master and slave. Both the setups will see it. So how to do the setups. Okay, so next thing is we have very important things called architecture. Okay, so before starting the interview, so they will ask about the basic questions like before going into depth into the Kubernetes. So they will ask the basic things. Okay, so first thing is, have you worked in the cloud or on-premises or managed services like that? Okay, you can tell that I have worked on the on-premises one, no problem. So they will ask about the next thing is, can you tell me the Kubernetes architecture? So why we require the Kubernetes? Okay, so what is the architecture of the Kubernetes? Okay, so Kubernetes will combination of the master and slave will be there. Okay, so master and slave is nothing but it looks like this. Okay, so okay, so if you take this is a master machine, and if you take this is a slave machine. Okay, so master and slave machine, it contains certain components are there. So those components is responsible to perform any activity in the Kubernetes activity. So if you consider this is a cluster, entire cluster. So cluster is nothing but combination of servers. So if we take, so this is a master machine and this is a node machine. Okay, so n number of node machines are there. So each node machine will have certain components, and also in the master machine also we have a certain components are there. So first component in the master machine is, so it's a API server. Okay, so API server is there. So we have a etcd scheduler, controller manager. Okay, so cloud manager. Okay, so API server is the main part in the Kubernetes. If you want to perform any activity, or if you are doing the interaction with anything like a node machine, or if you want to perform any activity, so all the requests will go to the API server. So if you want to do any activity in the node machine, so basically we have a one more terminology called the here. Okay, so if you want to create a provisioning of your deployments, or if you want to set up any application, so if you want to do the updations of the application, if you want to do the rollbacking of your application, any activity, if you want to perform it, so as an admin, Kubernetes administrator or the DevOps engineer, what we will do, so there is a separate roles are available. So specifically, they have selected only Kubernetes things. So the people who want to do the Kubernetes one, so there is a concept called certification. So if you do the certification on the Kubernetes side, so they will be hired only for the Kubernetes activities like admin activities and development activities. Two things are there. So admin activities is nothing but entire setup of your Kubernetes. So if you want to upgrade the cluster, if you want to degrade it, if you want to do the any change in the cluster level, so admin can handle it. So development work is nothing but application related activities. So deploying your application, accessing the application, whom you want to give the permissions. So what are the network rules? Okay, all these things will be done by the developer. So if you want to do any work in the Kubernetes cluster, so admin or the DevOps engineer, what they can do, so they can perform through kubectl commands. So kubectl is one type of technology or one type of a tool we can call it as. So with the help of the tool, so we can going to interact with a master service. So if you want to create any application deployment, so with the help of the kubectl, so we are going to send the request to the master. So the administrator will send the request to the master. So master always this request will be handling by the API server. Okay, so this is the backend part. Front end, we will not see anything here. So in the backend part, API server will take care of it. So if you want to store the information of your application related thing, if any updates are happening, if you want to roll back the things, so application is going to be redeployed. So all the information will be stored in the etcd. So etcd will be considered as a database for your cluster. So nodes related information. So any related information, all the application related or node related information, anything. So if you want to get the information, so all the information will be stored under the etcd. Okay, so here in the node machine, so what we will do the application deployments. So first thing is in master machine, application deployment will not happen. Only controlling part will be there. Master machine, application deployment will not happen. Only controlling part will be there. Okay, so what is meant by controlling means, so always your application deployed in your node machines only. So none of the application will be deployed in your master machine. So if you take the master node machine, so if you are deploying any kind of application, that will be always available in your node machine. Any number of applications you are deploying it, so it is always deployed in your node machines only. But in the master machine, single application will not be deployed. So to handling this application, so if you want to do the upgradations or degradations, scaling up and scaling down, rolling back, okay. So what are the operations you want to performing on the node machine? So that was handling by the master machine. So if you are doing any updations, so something, two applications are running. So I want to upgrade to the, like third application also went to run it. So always the request will be handled by the API server. So this activity cannot be performed by it. So this one, if you are able to, if you are doing any activity in the cloud means, so cloud manager will be responsible to perform the action. So based upon the request given to the API server, so the request will be checking. So which one this request can be handled. So if it is a cloud related activities, so the request will go to the cloud manager and it will perform the operation and it will give the response back to the API server, and API server will give the request to the admin. Same thing if you want to store any data, so that what API server will do. So what are the requests, it comes to the cloud manager. So what are the response we are getting it. So all the information will be stored in the etc. So etc will be considered as a database. So all the cluster information, okay. So master related information, node related, application related information, all the things it will be taken care by the API server, and the information will be shared across the respective components based upon the work assigned to the API server. Same thing if you want to scheduling here. So here we are going to use one terminology called pods. So what is meant by pod? Pod is nothing but, so as a Docker terminology, we have learned it, right? So pod is nothing but it's a container or collection of containers. Okay, so in your Kubernetes terminology, your most hearing word is pods. PODs, pods is nothing but, so it's a container, single container or collection of containers, means multiple containers we are going to call it as. So we can also call it as an application. Okay, so if you want to run in your application, so the pod will looks like collection of single container. So one is front-end application, one is back-end application, anything you take it. So all the things we will define under the pod. Okay, so this is a pod. Terminology, you remember it. Pod is nothing but it contains a container. Container is nothing but its application or collection of containers, means it contains one application or multiple applications. So that will be considered as a pod here. Okay, so here in the node machine, if you are deploying any application, it is nothing but this is one pod. This is second pod, this is third pod, fourth pod, fifth pod, sixth pod, like that. So this is one application. If same kind of application we want to maintain it, so then we are going to maintain the replica of the pods. Okay, so here this a pod is nothing but it's kind of application. So this pod, if you want to schedule into this particular node only. Okay, so if you have another node is there, so one application I want to schedule to the particular node only. So scheduling the pod to the node will be handled by the scheduler. Okay, so it is asking that I want to schedule this application onto the particular node. So the request will comes from the admin to the API server. Whenever he type the kubectl command, so the request will go to the master machine and the request will go to the API server. So from the API server, what we will do? So what kind of activity we need to perform? So the request is like, so we need to schedule a particular application into the particular machine, node machine, or we need to check the health status of the node or the pod. If it is not working, so the server itself, the node itself is gone down. So all these pods are goes down. So I want to schedule these pods to the another node. So scheduling and checking the health status of the node machine, everything will be handled by the scheduler. Okay, same thing we have the control manager. So the pods are there. Now the pod have 2 pods are there. I want to scale up to the 5 pods. So updating and rollbacking any request will comes. So the request will send to the control manager. So it will perform this activity in the node machine, and these node machines will be given response back it, and it will send back to the API server, and API server will send the request to the back to the kubectl. Okay, so this is the complete workflow of your master machine. So somebody asked in the interview question, can you tell me the Kubernetes architecture means? So Kubernetes architecture will have the two it's a cluster. We have a master and slave machines are available. So in the master machine, we have a certain components that API server, etcd, scheduler, controller manager, cloud manager. Okay, so cloud controller manager we can call it as. So what each activity will we do? So API server is the main thing for the master machine. If any request comes from the admin or the Kubernetes admin or any request which comes to the kubectl, so the request will goes to the API server. From that, so what type of activity we want to perform it based upon the command or the based upon the file which was request goes to the API server. So it will send the request to the respective component and it will perform the activity on the node machines and give the response back to the admin. Okay, so this is a scheduler. Scheduler, we can easily identify it, scheduling the pods to the node machine. So cloud related activity, AWS, Google Cloud, GCP, Azure, based on the cloud request becomes cloud manager, control manager. If you want to update it, rollbacking, anything operations you want to delete it, anything will be done by the control manager. So it will always wait for any API request is coming to any changes on the node machine. So this control manager will be able to handle it. Same thing etcd. So every activity you are storing it. Suppose you want to create a pod here. So the request is to the same will be the etcd. So same type of request is coming. So no need to perform the new operation. It will always check from the etcd. So if this already the performed operation means it will take from the etcd and it will give the result again. So no need to send the new request again. Okay. So those type of things we can perform in the master machine. Okay. Same thing also we have the node machine also we have certain components are there. So the 2 components which we have it, kubelet, Docker, proxy. Okay, so if you take the terminology like the node machine also, we have certain components are available. So the component is kubelet, Docker, proxy. So Docker, you know, so any node machine, if you are running any container, so the pod which is running means inside the pod, we are having the container. So if you want to run the container means Docker should be there in that particular machine. So if you are working with the containers, Docker should be the main component, like main software should be there inside your node machine. Okay, so kubelet and proxy is nothing but, so proxy, if somebody is talking about proxy means all the network rules. So network is nothing but your inbound and outbound rules. So what is meant by inbound rules and outbound rules, you know, right? So somebody from the user is trying to access this application. Okay, so whether this person outside the network, we have the access to the application, or internally inside the cluster, if you want to access the application. So all these network rules will be defined. If you are defining any network rules or the ports related enabling part, you are doing it. So this will be with the backend part will be handled by the proxy. Proxy is somebody's talking means it's completely deals with your networking, accessing your application inside the cluster or outside the cluster, exposing your applications. So all these things, application related accessing part will be taken care by the proxy. So the request will comes here. If you want to access it, the request will goes to the API server. So if you want to access the application or not, so based upon the configuration which we do it, so the application will be accessed. Okay, same thing how the API server is the main part in the master machine. Same thing here is the kubelet is the main thing. So in order to provide a communication between your master and the pods and application, so this is called as a one type of agent in each node machine. This agent will be running, and it acts as a communication between your pods and applications to the master server. So here how API server is handling the request. Same thing here also the kubelet will be handling the request between the, it acts as the interface between your master and the request which is sending by the API server. So the request will be handled by the kubelet, and it will process the request and give the response back to the API server. Okay, so these are the components which are very important, and then they will ask in the interview question, each and every component they will ask it. So we should remember the component, and if somebody asks about the architecture means, so this diagram should be registered in your mind. So without this means the Kubernetes architecture, definitely common question in the interview questions. Okay, so what exactly the components, what exactly each and every activity will do it. Okay, so if you see the terminologies, so we need to see. So first thing is kubectl. Okay, so next API server, controller manager. Okay, so next cloud controller manager, same thing. Next etcd scheduler. Okay, so these are the components of your master. So this is the request will comes from the admin, the person who is running the commands on the machine. Okay, that will be performed by your Kubernetes administrator or DevOps engineer. Okay. Next from the node side, so we have the kubelet, kubeproxy, and a Docker. Okay, so this is called as a complete architecture of your Kubernetes. Okay, so this is very important, guys. We interview question they will ask it. So in order to go deeper into the Kubernetes, so they will start with the basics. What is Kubernetes? Okay, Kubernetes is open source. It's a cluster management. So it is able to handle the multiple nodes. Okay, health status, we can easily scaling up applications, scaling down the application. We can easily manage the deployment in the cluster. Okay, all these things we can tell at the Kubernetes side. Then they will ask about the architecture. So next thing is we have a lot of terminology which is available in the Kubernetes. So we have a namespaces, pods. Okay, so deployments, services, config maps. Okay, secrets, volumes. Okay, so PV and PVC, persistent volume and persistent volume claim. Okay, so next this thing. Okay, so if you see about the Kubernetes thing, so we have lots of work we can do in the Kubernetes. So first thing is we need to know the terminology, what exactly the Kubernetes will do. Then we will go with the practical session. Okay, so first of all, what is meant by namespace? So in the Kubernetes, they will ask about the terminology about the what is namespace. So namespace is nothing but how we are seeing the AWS thing. Okay, so for example, this is an entire cluster. Cluster is nothing but it's a combination of servers, right? So what we will do, so if you take your AWS account, so this is a one region. If you take AWS, there are multiple regions are available. Okay, so if we take, this is a North Virginia. So this is Oregon. Okay, so what happens to this one? So when you're creating EC2 here in Oregon region, so we can't see the same EC2 instance in the North Virginia region. So AWS account is same, but in AWS account, the regions are different. Okay, So if you take the Singapore region, Tokyo, any region you take it, suppose this is an entire AWS account. In the AWS account, we have a different kind of regions are there. For example, you see here, I'm in the Tokyo region. So if I switch this Tokyo region to the something like a North Virginia region, okay, so same Jenkins server, same AWS account, same configurations and everything is there. But I don't see the server in the North Virginia region. AWS account is same, but the regions are different. But if you are creating the resources in one region, same resource we can't see in another region. Same thing we can correlate with the namespaces. Namespaces are nothing but, so the cluster will be same. Kubernetes cluster will be same. So what they will do? So they will do the divide the same cluster into the subclusters. They will do it. Okay. So the resources which we are creating in one namespaces, for example, this is namespace 1. This is namespace 2. Okay. So what they will do? So for example, this is AWS account. We have different regions. Same thing we can correlate with the Kubernetes architecture. This is a cluster. So if you are dividing the entire cluster into subclusters, so that we are going to call it as a namespaces. So what are the resources we are creating under this namespaces? So the resources we can't see in other namespaces. Okay. So everything, if you want to get the information, so we need to type, always we need to type the commands called kubectl. So if you want to get the namespaces, we need to type the namespaces. So every activity you are performing it, so we are going to request through kubectl. So it will be going to the master machine or respective component will go and will give the list of information for you. So how we are doing the Docker PS, how we are getting the list of containers, what is the container name? So from which image we are created, what port it is as assigned. So when it was created, what is the size of the image, all the information, how we are getting. Same thing when we are typing the Kubernetes related activities. So we need to always append the kubectl command. So if you want to work on the namespaces, first of all, we should understand the namespaces terminology. Then we need to know what are the operations, what are the commands we can perform with the kubectl. Okay, so kubectl is the very thing important. So it's a command line tool. So if you want to perform any activity, if you want to get any information, if you want to do any activity related to the application, so everything we will do with the kubectl. Okay, so namespace is nothing but, so entire cluster we are going to divide into subcluster. So we are creating our own namespace. So we need to check it, which namespace we are currently in. And if you want to switch from one namespace to another namespace, so what are the commands we can performing it? So then you can start creating the resources. Same thing here. So if you want to create EC2 instances, generally people will not see about the region here. Okay, so once you log out, so the default region is North Virginia, they will create it. So they will switch to some other region and they will check like this. So where is my EC2 instance? The last. So we need to be focused about the which region I have created the namespaces. Which region I have created the EC2 server. If I see the Tokyo region, one EC2 server is there. Same thing here also in the Kubernetes also. So which namespaces we are currently in. Okay, so all these commands we'll see now. So kubectl get namespaces will be the list of all the namespaces which are available in the current cluster. So the default namespace is here. So if you want to switch from one namespace to another namespace, we can switch it. So if you are doing any application deployment in this namespace, so this application related configurations resources, if you are there in other namespaces, we can't see the details of this information in other namespaces. Okay. So namespaces are nothing but it's dividing the entire cluster into the subcluster, and the resources which we are creating in one namespace, we can't see in another namespaces. If you don't understand the namespaces terminology, so we can correlate with the AWS. So AWS, we have the regions are there. So if you are creating the resources like volume, snapshots, security groups, anything we are creating in one AWS region, we can't see the same resources in another region. Resources are available, but the created one we can't see in another. Okay, so that is the concept of namespaces. So till now, clear guys? Any doubts, any questions?
No, sir.
Okay. So namespace is very important, guys. Organizing like, so I want to create certain resources like, so if you have a cluster here, so when the namespaces will be allocated is, so the company will give the only one cluster for the thing. So what they will do, the project wise, they will divide into namespaces. Okay. So cluster will be one. But if you want to go with namespaces, something like a project is there. So A project resources I want to give in the particular namespaces. Same thing like a B project is there. B project I want to create a resource in separate namespaces. Okay, so those type of things we are going to have in the namespaces. Okay, so this is very important, guys. Namespaces. So first terminology in the real-time scenario, you will checking about the namespace. So if you don't tell about the, we are using only one namespace means okay, fine. For the project, you are working on the single project, so they will allocate and give to the single namespace for you. So if you are working on admin side, so if you're handling the multiple projects, so we need to be know about the information about the namespaces. So this project is under which namespaces and another project is another namespace. So there are two things are there. UI will be there and command line will be there. So if you are working on the UI, no problem. You can see all the information from the UI. But if you are doing through the command based, so we need to get everything through the kubectl commands. Okay. So kubectl commands only we need to perform it and we need to get the information. Okay. So next thing is a pod. Pod is nothing but so how it looks like. Okay. So for example, this is a pod. Okay. So pod contains containers. It may be a single container or multiple container. So this is like a application one, app one. This is app two. Okay. So in pod, it is a collection of a single container, or it may be a collection of multiple containers we can place inside the pod. So pod is like a virtual thing. We can see the applications. So they will define the image here. So which port you want to expose this one. So the main important thing is like, so one port cannot be shared with another port. Suppose if this application is using 8080 port. Okay, so this application cannot use the 8080 port. Okay, so we need to go with a different port. So if the application is using application 3, so if it is there, so we need to go with okay. So inside the pod, there may be a multiple containers running, or we can use single container, we can run it. So each container or each application which has shared across. So this, if you want to communicate with one pod to the one application to another application, what we can do. So each pod which we are deploying in one node, that node will have the IP address. Okay. For example, in the node mission, we have deployed this pod. So in pod, we have a containers are there. So this pod, each container will be having the unique port. Okay. So if you want to communicate from one application to another application, so we can communicate via IP address. So for all the containers, the IP address is same. But if you want to communicate with the two containers and the two applications inside the pod, so they can communicate via IP address : port. Okay, so even if the all pods, all the applications having the same IP address, but application one will have the node IP address, port one. Okay, same thing, application one will have the same IP address, but the port will be different port. Okay, so IP address will be the same because they have deployed in the same node machine. So this application will have the same IP address. This application will have the same IP address. This application, but each application will have accessing will be the port will be different. Okay, so this is also one of the important interview question they will ask in the Kubernetes side. So if you are deploying the same application inside the same in the pod, we have the multiple containers already. So these containers are sharing the same IP address. So how they can communicate each other? So you can tell that each container will be running in the same pod, but each container will be running on the different port. So same port cannot be used by the two same applications or two different applications. We can't share it. So in that case, we can communicate via port. Okay, IP address colon port we can communicate within the two applications which are running in the same port or same pod or different pod. Okay, so everybody will have the unique IP address, unique port will be there. So like that we can communicate IP address port. Okay, so these are the pods. If you want to get the same thing information about the pods, so just we need to type the kubectl get pods. Okay, so how the pod will be like? So everything we have to write the YAML files. So this YAML file will have the predefined format will be there. Okay, so we need to follow that format. So just to go to the here pod example Kubernetes. Okay, so if you type it, so this is official website kubernetes.io. So select this pod. So this is the syntax for your pod. So for everything information, if you are writing anything, so it should be YAML file format. So this is the syntax for writing the pod. So in the real-time scenarios, you can get it from the internet. But for the intro perspective, we need to remember the entire syntax. So API version, kind, metadata, specifications, container, container image, container port. Okay. So API version is V1. This is a common, definitely common thing for all the YAML files. So kind equal to if you are working with a pod means we need to define the pod. If you are working with namespaces, so it will be replaced with namespaces. If you are working with deployment, will be deployment. If you are working with config maps, it will be replaced with config maps. So if you are replacing with secret, if you are working with a secret, so kind will be replaced with secret. Okay, so like that, based upon your work, whatever the work you are doing it, so it will be defined as a kind as a pod. So if you're working on the deployment, so the instead of the pod place, we can use deployment. So if you are working on the namespaces, namespaces. Okay, same thing if you are working on the secret, secret, config volumes, anything if you are working it will change. So what is metadata is nothing but, so if you want to give one name to this entire pod, right? So that metadata name is nothing but this pod name. Okay, so this entire pod, we are giving one specific name to us. So that name we are going to call it as a, so that we'll specify here. So this pod name is Nginx pod. Okay, so this entire pod, how many containers are running, we don't bother. So this pod, we are giving one name, that name we are specify here under the metadata section. Okay, so next specifications. So this container, we need to define it. So name, we can give the container name. Same thing, we want to give each individual one container, we want to give one name for here. So here also we can giving the one name for it. So this name is also Nginx name. Okay, so this is the image, and this container or this application is running on the port 80. So same thing. This is the image name and this is the port. So if you want to include one more container, so just what are the name here, you need to take it. Just will take here. Okay. So now I want to get Apache. Okay. So HTTP I want to install. So just I want to change like that. Okay. So pod is nothing but it's a collection of single container or multiple container. So container is nothing but it may be a software again, or it may be an application. So here there we are there in the Docker side, we are defining manually everything. So image exposing and everything. Here we are defining everything with a terminology. So this is creating one container, and container is running on the port. And this container we are giving one name. And what is the container? Version image. So we are not focusing on image creation. Already the image one which is there. So we are going to take the image here. Okay. So kind should be pod. This is the okay. So one more application or one more image we will specify it. So for that one we will assign the port. We will give a name for it. Like that we can define a number of applications inside the pod. Okay. Understood, guys? Any doubts, any questions?
No, bro. Fine.
Okay, so tomorrow we'll see some more concepts like terminology. We'll see what is exactly definitions. So tomorrow we will see again the installation part. If you want to go with a single cluster, single node machine, and a cluster setup like master node setup, we'll see it. Then we'll start working on the examples, how the commands will be there. So how to write the YAML files and everything we will see. Okay,
Bro, same timing.
same time. Arun and Satya, you are available right tomorrow, Saturday?
Yes, sir, we will be able.
Okay, open the link.
Bro,
and
I'm morning time not available, 7 to 8.
Oh, okay. 8 to 9 is possible.
Oh, 8 to, after 10 o'clock is possible, bro. Why? Because of రేపు నేను జర్నీలో ఉంటాను ఆ టైంలో.
Okay.